Hello, everybody. Hope you guys are doing well. Happy New Year to you all. And today I want to do something a little different. I want to go through the slideshow that I prepared talking about the four organs that are used for handling the digestion and metabolism of animal fats. Now, I hope this video can communicate that we are in fact carnivores and that our human body is made up of these organs that actually help us to digest animal fat instead of people claiming that animal fats are bad for you and cause heart disease or cancer or whatnot. So we'll go through this and I'll try my best to explain it in a way that you guys can understand without getting too much into detail. Just a little disclaimer to begin with, I have not included the stomach in here, and if I was to include it, it'd be 5. But the stomach does play a minor role in digesting fat, in which when you eat a fatty meal, it goes through your stomach first and it's mechanically mixed with lipase, which is an enzyme, and that helps to prepares the fat for metabolism and absorption into the body. So without further ado, let's get straight into this, and I'll try my best to make it as beginner friendly as possible so you guys can understand. So the first organ that we're going to talk about is the liver. So the liver makes bile from water, cholesterol, and bile salts. Think about there's two ends to a bile salt. There's a water loving end and there's a fat loving end. So they act almost like a detergent. The average adult produces around 400 to 800 ml of bile a day, and bile is also responsible for carrying out waste products such as excess amounts of cholesterol and old red cell pigments, so that your blood is always fresh and red. The liver also repackages the fats that you eat into VLDL and LDL lipoproteins. And lipoproteins are really significant in fat absorption and digestion because they deliver energy and building blocks to the rest of the body. They act as little messengers. Think of it as like a little package full of nutrients that are carried around your blood into certain areas of the body. Now, a lot of bile salts are actually reabsorbed in the final section of the small intestine, which we'll talk about later when we get onto the small intestine. So yeah, that's pretty much the liver's role in it. It helps to make bile salts, which are extremely important for the digestion of fat. Next up, we have the gallbladder. So between the meals that you guys eat, bile synthesized from the liver backs up into the gallbladder, which is this little thing here. And you see how it's connected here to the liver. It backs up into the gallbladder and it becomes very concentrated here. So when dietary fat enters the small intestine, the cells within the small intestines release a special molecule called CKK. And what CKK does is it triggers the gallbladder to contract. And when it contracts, it releases bile into the small intestine when needed and aids in breaking down dietary fat when it gets to the small intestine. People who go on a low-fat diet for an extended period of time, they have lower amounts of CCK being secreted, which means the gallbladder gets emptied a whole lot less. And this can lead to certain health complications such as gallstones and actual removal of the gallbladder because it constantly needs to be releasing those bile salts and bile into the small intestine so that it gets emptied and it doesn't give those bile salts and bile the chance to harden and create a inconvenience for the body. If you know someone who does have their gallbladder removed, people without their gallbladders can still actually digest fat. Bile just drips continuously from the liver, but the timing is a whole lot less precise. So instead of being stored up in here in the gallbladder, basically what it'll do is it's just as it's made, it continuously just drips into the small intestine without the involvement of CCK. Next up, the pancreas. So the pancreas basically excretes enzymes that are crucial for metabolism of fat, and these include enzymes that help neutralize stomach acid, which is bicarbonate, which provides a clean and helpful environment for enzymes to work in. The pancreas also cleaves triglycerides into monoglycerides and free fatty acids. Enzymes even allow for the lipase to continue working even in the presence of bile salts. So it's all very interconnected on a very cellular level, and there's a whole lot of processes working together to ensure that we are breaking down the dietary fat and absorbing it in a clean way. Basically, all you need to know, the pancreas is very important. There's a lot of enzymes that just help with, making sure that everything works together as one, instead of, having one thing cancel out another because of incompatibility of certain processes working together. Finally, the small intestine. Now, the small intestine is made up of 3 different sections, but in this section we'll just talk about the duodenum, which is the first part of the small intestine. Bile salts and lipase break down fat into microscopic micelles. Micelles are very small molecules. So micelles carry fatty acids and cholesterol and fat-soluble vitamins such as vitamin A, vitamin D, vitamin E, vitamin K through the watery layer to the intestinal wall. Now, inside the enterocytes, which are little cells within the intestinal wall, the fatty acids are then rebuilt into what are triglycerides and packed into chylomicrons. Chylomicrons then enter the lymphatic system through the villi of the intestine, which are little finger-like projections from your small intestine. But basically, as I was saying, in the villi, they enter the bloodstream through through a duct in the small intestine called the thoracic duct. And your muscles and your adipose tissue all around your body extract the fatty acids through lipase. And the liver then later clears the remnants and recycles them into new lipoproteins. So the whole process can be repeated over. It's very sustainable. So that's pretty much the gist of it. I tried to make it very introductory, very not too much in depth, so that way you guys watching can hopefully understand. If not, leave a question. I'll try my best to answer it. I'm still working on trying to explain stuff better and trying to improve my speaking skills. I think it's very important that we understand how the anatomy works and the physiology works behind it all, because it's one thing for me to just sit here and preach about, wanting to eat meat all the time. It's a big step, it's a big change, but I think if I can slowly give you guys the facts, the anatomy, the anthropology, the physiology behind it all, that'll make the transition a whole lot easier for those wanting to try it, or can give you a bit of reassurance that it's not going to kill you. So that's pretty much it for those organs and what they do. The bottom line of it all, behind why we do thrive on fatty meat. So compared to herbivores, humans have a large liver and gallbladder relative to body size. This shows adaptation to energy-dense food, and food that has a lot of dietary fat is more energy-dense than, say, stuff that doesn't have a lot of fat. And that just leads on to my next point here, which says that fat supplies around 9 kilocalorie of energy per gram. This is over twice that of carbohydrates or protein. So it's efficient fuel for the large, ever-hungry human body that requires a lot of energy. The human brain is about 60% fat, which is very important for when we are considering eating food to fuel our brain. We want to be fueling it with ketones and fats as well, DHA, EPA, all those nutrients and stuff. We don't really want to be fueling it with sugar, because the brain can make its own sugar, or the body can make its own sugar when needed through a process called gluconeogenesis. And I will go through gluconeogenesis in more detail in a further video. Fat digestion allows absorption of fat-soluble vitamins and nutrients, which are essential for health and other bodily processes. Now, these processes and health benefits include stuff such as, vitamins, immunity, bone health, and, antioxidant function. There's actually a lot of vitamins that are found in the fat of animals that you can't get anywhere else. So it's actually very important that we are eating dietary fat to get those nutrients. And the final point I want to make is that our small intestine is proportionally longer than the colon. And what that means is that it actually favors, when the small intestine is longer than the colon, it actually favors absorption of fats and proteins rather than the fermentation of fibrous materials that you may find in plants. So that's pretty much going to do it for today. It's a very introductory slideshow. Hopefully you guys learned something new from this. I try my best to explain it in a way that you guys can understand without getting too confused on the whole process. If you guys did, feel free to ask me questions. I will try my best to answer them in a way that you can understand, because that's what the whole idea behind this is. It's just getting the message across, getting it out there for you guys to understand and to learn something new, nudge you in the right direction when it comes to diet choices. Appreciate you guys dropping in. Leave a like if you guys like the video. Share it to someone who may benefit from this, or someone who needs to hear this. And I'll see you guys in the next one. Cheers.